Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue with chapter number 5, Prime Time of Grade 6 Mathematics of the new Ncert textbook, Ganitha Prakash. So here, which co-prime numbers for safe-keeping treasures, okay? So you remember Jumpy and Grumpy, right? So again, they are playing that they are going back to the treasure finding game. So which pairs are safe, right? So now this time the treasures are kept on two numbers. Okay. Now Jumpy gets the treasure only if he's able to reach both the numbers with the same jump. Okay. And there is a condition that jump 1 is not allowed, because if jump 1 is allowed, then he will be able to reach by jumping 1 1, right? Now, where should Grumpy place the treasures so that Jumpy cannot reach both the treasures at a time? Okay, or with the same jump size, right? So let us see. Now, while placing this treasure, here they have given an example of 12 and 16. Will this work? So 12, what are the factors of 12? Factors of 12 are 1, 2, 3, 6, and 12. 4 and 12. These are the factors of 12. If we see about 26, 1, 2, 13, 26. So here we have a common jump size, that is 2. Right? If you see, 2 is common in both. Right? So Jumpy can easily select 2 and then reach the treasure. Okay. So 12 and 16 will not work. Let us see another example. What about 4 and 9? Jumpy cannot reach both using any jump size other than 1. Grumpy knows now, Grumpy has understood that 4 and 9 is safe. So like if I talk about 4 and 9, what are the factors of 4 are? 1, 2, 4. Factors of 9 are 1, 3, 9. So there is nothing common other than 1. And 1 you cannot take the jump size as 1. That was the condition. So now Jumpy has understood that this 4 and 9 is a safe pair, safe treasure pair where he can keep his treasure. So they have asked, check if these pairs are safe or not. So let us see 15 and 19. So for 15, the factors are 1, 3, 5 and 15. For 39, the factors are 1, 3, 13, 13 3s are 39, right? 39. So is there a common factor? Yes, there is a common factor in between both. So that is 3. So Grumpy can easily choose this pair. This jump size is 3 and he can reach the safe. Okay. So this is not possible. Let us see another jump size as, like, let us check for B, question B. 4, the factors of 4 are 1, 2 and 4. We already did it here. And factors of 15 are 1, 3, 5, 15. Here nothing is common other than 1. Right? So 4 and 15 is a safe treasure numbers. Okay. Now question number C. The number is 18. So factors of 18 are 1, 2, 3, 6, 3 6 are 18, 2 9s are 18 and 18. These are the factors of 18, and 29 is a prime number. So only 1 and 29. Right? So this is again a safe pair, 18 and 29. Let us try with question number D. Let me choose a different color so that it doesn't mix up. 20 and factors of 20 are 1, 2, 4, 5 and 20. Factors of 55 are 1, 5, 11 and 55. So is there anything common over here? Yes. What is common is 5. So Jumpy can use the jump size 5 and reach the treasure. So again, this is not a safe pair. Now just observe the safe pairs, the ones which we have just selected and understood that 4 and 15 are safe pairs, right? So there is nothing common, so it is safe. Now you see 4 and 15 both are not prime numbers, but they are co-primes. Individually, if you see, this is a composite number 4 and 15. Both are composite number, but still they are co-primes. Co-prime means they should not have common amongst themselves, right? They may not be prime, both may not be prime. Okay, so both may be composite numbers, still they can be co-primes. So what is special about safe pairs? They don't have any common factor other than 1. Okay, so that is important about, and they are known as co-primes. The safe pairs we tell it as co-primes. If they have no common factor other than 1. Now here example is given as 15 and 39. They have 3 as a common factor, so they are not co-primes, right? And if the other example like 4 and 9, if we see, they do not have any common factor other than 1, so they are co-prime pairs. Got it? So here some questions are asked. Which of the following pair of numbers are co-prime numbers? Okay. So let us try to solve one by one. So question number 1a, 18. The factors of 18 are 1, 2, 3, 6, 9 and 18. And the factors of 35 are 1, 5, 5 sevens are 35. Does not come in the table of 2, 3. And then always write the factor pairs. 1 into 35, 2 it doesn't come, 3 it doesn't come, 4 it doesn't come, 5 sevens are 35. So if you make pair, then you will get all the factors. Otherwise, you may be wrong. So this, if you see, there is nothing common in both of them. So here you can say that they are prime numbers, co-prime numbers. So you can put a tick mark for this. Okay. Let us try to solve question number B. In B, 15 and 37. So 15, the factors are 1, 3, 5 and 15. For 37, the factors are 1 and 37. So there is nothing common again here. 37 is a prime number. Co-primes. So 37 is a prime number, so it will have only 2 factors. Correct? Let us try to solve question number C. In C, the numbers are 30 and 415. So now, sometimes if you are just asked to decide whether the numbers are co-primes or not without showing method, so you can see that the last digit here is 0 and 5. So both are divisible by 5. Okay, so they will have 5 as a common factor, so they are not co-primes. You can easily decide by using the divisibility rules. Okay, you have learned some of the divisibility rule in standard 5. We'll also learn in the same chapter little later. Okay, but looking at this, you can decide. We can also find out the factors. So let us do that method also in detail. So if it is just an objective, you can decide by looking at these numbers. 1, 2, 3, doesn't come in the table of 4, so leave 4, 5, 6, 7, not 8, no, 9, 10. Okay, and then 15, 30. You should see the pairs. 1 into 30, 2 into 15, 3 into 10, and 5, 6 are 30. So these are the factors of 30. 4, 1, 4. Now 5 is at the end. Okay, 2, it's not even. 2, 3, it doesn't come. 4, it doesn't come. We directly go to 5. So 5, 8s are 40 and 83. 5 is a 40, 1 is a 83, which is a prime number. So these are the four factors of this. But there is something common. What is common is 5. So they are again no, not coprimes. We already decided that, but this is the method. Okay. Question number D. D in D 17 and 69. So factor 17 is a prime number. So it will have only two factors. 1 and 17. And 69, the factors will be 1, 3, 23 and 69. These are the four factors. Nothing is common, okay, other than 1. So they are also coprimes. So in question number E, the numbers are 81 and 18. So factors of 81 are 1, 181s are, and comes in the table of 3. So 3 27s are. You can write like this. Earlier also I taught you this method. 1 into 81, 3 into 27, and then 9. 9 nines are 81. So 9 will be repeated. Okay. So 9 we can write just once. So these are the factors of 81. Now if we see 18, factors are 1, 2, 3, 6, 9 and 18. So you can see common numbers here. 3, 9, both are common. So they are not coprimes. Again here you could use the divisibility rule. 8 plus 1 is 9 and here 1 plus 8 is also 9. So both will be divisible by 3 and 9. So they have a common factor, so they are not coprimes. So while playing the Idli Vada game with different number pairs, Anshu, she observed something very interesting. So first thing which she observed is sometimes the number, the first common multiple was the same as the product of the two numbers. Means if you take two numbers like 4 and 9, if we take the example, then their product means 4 nines are 36 will be the first multiple. So let us check for 4 and 9. So for 4, the multiples are 4, 8, 12, 16, 20, 24, 28, 32 and 36. Okay. And if we see for 9, 9, 18, 27, 36. So first common multiple is 36, which is their product. So 4 nines are 36. Now what is special about 4 and 9? They are coprime numbers. Coprime. So whenever the numbers are coprimes, if they do not have any other common factor, then their product will be their first common multiple, that is their LCM, least common multiple. Right? So this is very interesting and important. Second thing what she observed it, at other times the first common multiple was less than the product of the two numbers. Okay, so suppose we take 3 and 9. So 3, the multiples of 3 are 3, 6, 9. For 9, 9. So their first common multiple is 9. Okay, common multiple is 9. And what is their product? 3 nines are 27. So 9 is less than 27. It is less than the product of both the numbers. So we have given examples. Now here what 3 and 9, they are not coprimes. So what is most important here you need to remember is what is important here you need to remember is two things. If the two numbers are coprimes, then their product will be their LCM, that is least common multiple. But if they are not coprimes, then the product will the LCM would be less than the product. It may be, it may not be, but they are not coprimes, right? So we will continue with this chapter in the next video. Thank you.